wasn't actually sure that was going to work. Hello Internet, my name is Quinn and this is Blondihacks. Today we're going to make one of my most requested projects, a machinist hammer. This is a great weekend project for beginners, so let's go. I'm going to do this entirely on the lathe. This is for those of you who don't have a mill yet. There's one step here that was probably easier to do on a mill, but I want to show you that you don't have to. Now, a machinist hammer is different than other types of hammers in the sense that it's a very light-duty hammer. You can make it out of just about any material that you want, because it's not a blacksmith hammer. It's not going to see a lot of heavy use, so you don't have to make it out of drop-forged dwarven mithril tool steel. This is just for tapping on things. A hammer like this is primarily used for tapping things in a vise on a mill or in a four-jaw chuck, or tapping things straight when you're indicating on them, things like that. So the whole point is that the materials of the faces are softer than whatever you're hitting. So in this case, I'm going to use steel for the handle, brass for the head, and I'm going to make two different ends, one out of Delrin and one out of copper. Now here's a look at the inside of the head, and you can see how space is pretty tight in there. I was originally going to make this into a dead blow hammer by making a hollow space inside and putting sand or lead shot in there, but there really isn't space without making the head of the hammer quite a bit larger, and the whole point of this hammer is that it's small and delicate and can get into small places in the hobby machine shop. All right, let's get started with the handle. I've got some 12L14 round bar here from the junk pile, and I'm going to start by center drilling the end here. It's got a leftover shoulder on the end of it there, but I'm just going to disregard that for now. I'm not going to bother trying to face it off. I'll bring in some tail support and I'll get some coolant on there and start turning the outer diameter of the handle. The handle is basically 600 thou in diameter all the way down, except for the very end, which is threaded to go into the head, and then there's a reduced diameter section in the middle for aesthetics. The blue goo that you saw there is a 50-50 mix of water and cool mist coolant solution, something I'm trying in lieu of sulfur cutting oil. It smokes a lot less, and I've read on machinist forums that it works almost as well, so I'm giving it a shot. I think the jury's still out on it. Okay, we're doing our finishing pass here, and let's check our measurements in 3 places to see if we have any taper. I'm expecting some taper because it's such a long part, but actually I got within half a thou all the way down, which is a pleasant surprise. And boy, you know, sometimes the stars just align. That surface finish is outstanding. I was planning to polish this, but it honestly doesn't need it, so I'll take those wins anywhere I can get them. Then I blued and marked my diameters. So I've got the threaded area at one end, the reduced diameter in the middle, and that down there is going to be the handle. So I'm going to start by turning down the threaded area at the top here. So this needs to get threaded down all the way down to the major diameter for a 1/2-20, which is the thread I'm going to use here. So after that first pass, I set an indicator so that I can hit my same mark on that shoulder each time. This is going to be threaded with a die, and I like to be 4 to 5 thou under major diameter for that, and we are at 494 and change. Perfect. Moving on now, we're going to cut the reduced diameter section in the middle. So I'm going to start by going in with a grooving tool, and I'm going in a little inside of the line on each side, and I'm going into the final diameter for the reduced diameter section. I do that at both ends, then I can come in and turn down the area between those grooves. And it'll make sense here in a moment why I grooved inside the lines instead of right on the lines. And that's turning very nicely. And then on my finishing pass, I'm just very careful to touch off in the bottom of that groove and feed across, and the surfaces will blend together nicely, and there should be no sign of having made those grooves. Now I can come in with my chamfering tool and touch off with the point on the inner diameter very gently so that I don't mar it up, and then move across to that line, and it'll finish out the diameter and leave me with a chamfer exactly on my line. This is a good time to get rid of that Sharpie, so I got some acetone there, and that's very satisfying to remove. And now let's knurl the handles. I've got my knurling tool in here, so I'll set this up. Lots and lots of cutting fluid with knurling, and relatively low speed, and I've got a slow feed on there, so I crank it down to the final depth that I want on the knurl, and then I just feed it across and keep it nice and lubricated. It's feeding very, very slowly because the lathe is running slowly, but it's actually on a 5 thou per revolution feed rate, which seems to be working quite well. And then I go as close to the chuck as I dare, and then stop it. And that looks adequate. Now, since I didn't face the end off like I probably should have, I came in with this 55-degree tool. It lets me get really close to the center and just faced off as much of it as I could, and then chamfered those corners. And we'll finish off that end here in a moment. Oddly satisfying. Time to thread the end now. So I've got a 1/2 inch 20 die in my tailstock die holder. And that's a nice looking thread. I jumped the gun a little bit on cutting this thread. I really should have cut the thread relief at the base first, but that's okay. We can do it now. So I've got a 1/2 round tool here, and I lined it up on the edge of my shoulder there. And I'm just gonna plunge this guy in and make a nice little curved relief there. A relief like this serves a couple important purposes. It gives you a runout area if you're single point cutting the thread, but it also ensures that that shoulder will seat tightly against whatever it's mating with. And we give it that curved profile to avoid the 90-degree corners you get with a grooving tool that would create stress risers. Time to part it off now, and this makes a funny noise as we first encounter the knurling with the parting blade. Now we want a chamfer or a fillet or some kind of nice detail at the bottom of the handle here, so I'm going to stop part way through, and then I'll come back in with my chamfering tool and put a very generous chamfer on there. Once I'm happy with that, then I come back in with the parting blade. When parting off a very long piece of stock like this, I'll go in part way with the tail support in as I had done there, and then I remove it when I'm close to the end. And I'm supporting it a little bit with that cardboard to keep the part from sagging and binding up the groove that the parting blade is in. And Yahtzee. And there was never really a good time to finish facing off that end that I should have done right away, so I'm going to come back in and do it with a file. And of course I could have set up a steady rest or some shenanigans, but I think people forget that you can do pretty much everything with a file if you're willing to just have a little patience. Okay, the handle is done. It's looking pretty decent. So we'll move on to the head next, and I've got a piece of brass scrap here. So we'll get this guy chucked up, and I've got a lot of stick out here, but I'm pretty sure I can get away with facing it. Brass is really easy to cut, and that worked out actually really well. My tool height needed a little adjusting there, so I faced it again, and now we're looking good. And we have about 10 thou of run out on the end of that part there, which is typical with a long part in the 3-jaw, so we can just tap that guy in, get it straightened out in the jaws. Couple more taps, and now we're within 2 thou there. So looking good. That's about as straight as we're probably going to get it. And just because I'm fussy, I'm going to face it one more time, because after we straightened out the stock, that end is technically no longer square to the lathe. And now I'm going to turn the outer diameter, and I'm just doing a light finishing cut here because I want to basically have the head end up the same OD as the stock. The stock's 1 inch nominal, and that's about what I have in my drawing for the head. This dimension isn't critical as long as the end caps match. And then I'm just going to kiss it with the file there. I don't want to chamfer that edge. I just want to break the sharp corner. And now let's take a little ride on the tailstock. So we'll start by center drilling the end here. And we're going to make the hole for one of the hammer faces to thread into. So we'll switch out to a pilot drill here. Now we need a pretty precise depth, so I've got a 20 thou feeler gauge there that I locate the end of the drill on the work, and then I set the hand wheel to -20. And then when I feed in, I know when the hand wheel hits 0, the end of that drill is on that surface. We can't touch off directly on the surface because of course there's a center drill there now. Okay, switching out to the tapping drill size now for 7/16 20, and I'm again using the 20 thou feeler gauge there, and we drill this into the same depth. Now when using a Q-tip to clean out a bore, make sure not to enter the ear canal itself, that's very important. Now I use the end of the work to square up the tool post and then come back in with a chamfering tool and chamfer that inside edge. Time for the spring-loaded tap follower. You may have seen me make this in a previous video. And I'll bring in my 7/16 20 taper tap to start with, and I'm using WD-40 there as a lubricant for this brass. And we tappy tap tap that guy. And then I come back in with a bottoming tap since it is a blind hole and it's not especially deep. We need all the threads that we can get in there. That's looking very nice. And just for giggles, I don't have any 7/16 hardware to check it with, but I do have this thread checking tool. There's a link to this guy in the description below if you would like one. It's a very, very useful thing for hardware scrounging hobos like myself. The threading kind of messed up my chamfer a little bit there, so I'm going to go in and redo it. I want to make really sure that those hammer faces are going to seat perfectly flush on the ends of the head here. We've done all we can in this setup, so I'm going to mark up the end here for length and part it off. And Yahtzee. We're going to leave the head partially finished now because we can keep the 3-jaw chuck here and use it to make the hammer faces. So the first one is the Delrin here. So I've got a piece of that. The non-trade name of this is acetal. It's a very popular machining plastic. I'm going to start by facing the end, as is tradition, and you can see that I'm using an aluminum tool here. Officially, the top rake for Delrin is supposed to be something like 20 degrees. In practice, it's so easy to cut that it honestly doesn't seem to matter what you use. The stock is once again a 1-inch nominal OD, so I'm just going to take a light facing cut and get it to the same OD that the head happened to land on. And here you can see how Delrin makes these thin stringy chips that wrap around the work and even the chuck, and this is why a lot of machinists really hate this stuff. But I'll show you a trick here in a minute that makes Delrin actually a joy to work with. So that's looking really good there. Now I've got a shoulder turning tool here, and I'm just making sure I'm going to have clearance on both sides of that because we're going to turn a deep shoulder. And now I'm going to face the end one more time. I do that because now I know that the tool is exactly on the end of the work, and I can set up a dial indicator and just dial into the depth that I'm going to want for this shoulder, and then reset my indicator once again with a light preload and zero it. So this is an easy way to get a very, very precise depth. Not that it matters especially for this part, but it's a good technique anyway. You just need 3 things to make Delrin a joy to turn on the lathe: a magnetic indicator stand, a zip tie, and a shop vac. Set that guy up, point it at your tool, and look at that, like magic. It's like the chips never existed. Delrin never breaks a chip, it just makes one long string. And whatever you do, don't grab onto that string while the work is spinning. It's very tempting to do that, to pull it out of the way with your hand as you go, but that's a surefire way to lose a finger. That Delrin string has a lot of tensile strength, and it's going to wrap itself around your finger, wrap itself around the work, and there goes your fingers. So the shop vac trick takes away all of the danger, makes Delrin very, very pleasant to work with. This area is going to be threaded, so just like we did on the handle, I come back in with my half-round grooving tool and make a little thread relief there. And then I come back in, chamfer the end, and much like before, I'm just kissing the edge of that with the file just to break the sharp corner. And now we can thread this guy 7/16 to thread into the head, and Delrin threads just comically easily. The only thing is it picks up all the crap from the threading tool there. And now let's do a little test fit and see if that threads into the head nicely. And boy, does it ever. That is incredibly satisfying. Now I'm just going to use the scale to set my parting blade to the right depth. Just by eye here is good enough. And I'm going to go in part way, and then once again come back in with the chamfering tool. And I'm just chamfering this a little bit because it's going to mushroom over anyway. The chamfer will delay the mushrooming somewhat. It's mostly aesthetic. And Yahtzee. Onto the copper face now. For this, I've got this beautiful piece of copper round bar that was donated to the channel. Copper is not cheap, so I'm super grateful for this donation. Now this might be regular copper, or there's a chance it's 110 free machining copper. So let's find out. I'm going to face the end off here, just like we did with the Delrin, and that's turning really, really beautifully so far. I'm once again using my aluminum tool there. And then once again, I'm turning the OD with just a light finishing pass to match the OD of the head, which is slightly under 1 inch. Goodness gracious, this is turning beautifully. I think this must be the 110 free machining copper, because regular copper is a real pain in the patootie to machine, and this stuff is just beautiful. I'm in love with whatever this is. Now I've got my shoulder turning tool on there again, and I do the same trick with facing the end and then setting up the indicator, and now I can turn my shoulder. Now this is a zero rake tool that I mainly use for brass. I wasn't sure how it was going to work on this copper, but actually it's working really, really well. It's turning a beautiful chip. I experimented with deeper and deeper cuts just to see how much I could get away with. I think I topped out at 80 thou, and it was still cutting just fine. It could probably go more than that, so this is cutting beautifully. On each roughing pass, I was stopping a couple thou short of final shoulder depth, and then on the finishing pass, I go all the way to 0 on that indicator, lock the carriage, and wind out, and we end up with perfect dimensions and nice finishes on both surfaces. And once again, just with the file. And just like with the acetal, chamfer the end, and then come back in with my half-round grooving tool and make a nice little thread relief at the base there. Once again, mainly to ensure that the shoulder seats nicely against the face of the hammer. One of the less awesome properties of copper is that it really doesn't take a thread well, so we'll see how this goes. Seems like it's going okay. Let's take a look at that thread. And yeah, actually that came out a lot better than copper usually does. It's certainly not as nice as the other threads. You know, there's tearing and stuff in it, but it's much nicer than copper usually threads. A test fit on there once again, and ooh, that's beautiful. It's really satisfying when two identically diametered parts are threaded together. And in we go with the parting tool, and then the chamfer tool, and I try to just visually match the chamfer on the acetal end as best I can. Again, it's going to get mushroomed over as soon as I start using this thing anyway. And then finish the part, and Yahtzee. Alright, I've done everything I can with the 3-jaw chuck now, so I'll swap over to the 4-jaw and finish up that head. We've got a couple more operations to do on that. First things first, I bring the head back in so we can finish it up. I've got the sides protected from the jaws with some aluminum can there, and I dial this guy in, and then I'm just going to face off that little nubbin there off the end so it doesn't interfere with the center drill. And then I center drill, and tap this end just like we did the other end. So I won't bore you with all of that again. Next, I'm going to flip 2 of the jaws over on the 4-jaw, and I'm going to clean them while I have them out. It's always a good opportunity to do that. And we're going to drill the hole that the handle threads into. So I'm going to hold the head sideways like this in the 4-jaw. And I tried to use the outer step on those jaws, and I didn't have enough room to do that, so we're going to have to use the inner jaws. And so I've got some aluminum can on there to protect the sides of the part, and then I'm going to clamp on the ends of the part as well. And if you wanted to be really fussy, you could protect the ends of the part with aluminum can. I didn't do that, so it will mark up those ends a little bit, but it'll be inside the hammer where you'll never see it. I'm indicating the ends using the same technique you use for square stock in the 4-jaw, basically moving it up and down until you find the smallest reading there, and that's when you know that side is vertical. And then I tap this guy in to make sure that it's seated on the jaws because it tends to move in that process. Now for indicating on the short sides, I can't reach the material with the indicator, so I'm cheating a little bit here and I'm indicating on the jaw itself. This is kind of a last resort because this is assuming that my aluminum shim and everything is all perfectly even on both sides. It may not be, but this is certainly going to get us close enough here. So I don't have enough travel on the indicator to pull it clear of the jaws between each measurement. So after I check each side, I pull it off to the side and then flip the part 180 and then bring it back into the same place on the jaw each time. It's a little bit tedious. And then after doing all that, I tap it in again and then check the other dimension again just to make sure it hasn't moved and go back and forth until everything indicates correctly. And now we are ready to start drilling this hole. So I'm going to center drill it here, just like cross drilling on a round part in the mill. You want to start with a center drill and peck at it carefully just to make sure it starts exactly on the crest of that convex surface. And then I come back in with a pilot drill, and again I used the feeler gauge technique here because the depth here is quite important. We don't have a whole lot of wiggle room inside the head there. Once that's pilot drilled, then I can come back in with the tapping drill size for 1/2 inch 20, which is what we're going to use to match the handle, of course. Now that's looking quite nice, except that there's a 118-degree drill cone in the bottom of that hole, and we need a flat bottom. Now you could come in with a boring bar, however you can't generally do it in one pass. The shape of the cone is such that there's too much material for one pass with the boring bar, and so you have to do it in multiple steps, and it can be a little tricky. It's certainly doable, but here's a trick that makes it quite a bit easier. Get yourself a Morse Taper 2 end mill holder, put a piece of all thread in the end to make it long enough for the tailstock to be able to eject it. And then I put in a 2-flute end mill there, and I just go in with that to the exact depth, again using the feeler gauge to get the depth correct, and I just go in and flatten out the bottom of the hole. Now that end mill is a little smaller than the hole, so you can see I've got a little step still in there, but that step then is easy to clean up with the boring bar, which I should do next, but I forgot to do, and instead I went in and started threading. And I noticed that I couldn't get the thread depth that I wanted, and that's when I remembered I had forgotten to bore that little step out of there, so I was able to go back in after the fact go around the thread and bore out that little step, and then come back in with the bottoming tap and finish that out. Now back to the boring bar to counterbore that for the top of the handle to seat into. So once again, I touch off, set my indicator to get the exact depth, and in we go. So I'm counterboring this to 600 thou diameter to match the top of the handle, and then the depth has been calculated in CAD to make sure that the entire top surface of the handle will disappear inside the head to look really nice. As I went along here, I'm using my telescoping gauge to check our progress, and I also sometimes call these snap gauges just to enrage commenters. Okay, moment of truth. Bring the handle back in and let's do a test fit. That should thread in there, and then the top part of that handle should completely disappear inside the head so that you can't really see how the two pieces are joined together. It should look really nice if we did this right, and oh, that's beautiful. Look at that. I just love that effect, and it's very easy to achieve with just a little bit of math. Thank you, Mr. Lathe. We are done with you for this project. Let's go over to the bench now and finish things up. Got a little bit of a parting nubbin there on the acetal end, so I've got a razor blade there to knock that off because it is just plastic. And then for the copper end, I used a combination of a file and a little bit of 400 grit emery on a piece of glass, and that is looking entirely serviceable. And of course, none of this matters because we're about to hit stuff with this. For final assembly, I'm cleaning up the threaded areas with acetone because everything's going to get Loctited together. That's quite important because as there's impact forces, you're hitting stuff with this is a hammer after all. The threaded sections will unthread themselves. I found that out the first time I made one of these hammers. I'm using Loctite 603 on the metal-to-metal connections. So that's the handle into the head, looking good. Same with the copper end into the brass head. For the Delrin end, I'm using regular super glue. Now technically, most Loctite products, including 603, are actually cyanoacrylate based, but they have something in them designed for metals, and I don't know if it'll work on plastic, so just use super glue. And a little buff. If I do say so myself, that came out so nice that it's kind of a shame to go and hit stuff with it. But that's what it's for. This is a fantastic beginner lathe project. This is a great project number 3, something like that, after you've made some bushings and some knobs, things like that, and you want to make something real, a little more complicated with multiple parts. This is a great thing to do. I hope you enjoyed watching me make it. I hope you will make one too. Thank you very much for watching. Consider throwing me a little love on Patreon, and I'll see you next time.